Now in this video basically we'll do some Lewis-Dot structure. So this is regarding the problem of Lewis-Dot structure. So we have already discussed the theory part. So this is Lewis-Dot structure. So let us say we have to write Lewis-Dot structure of some molecule. First molecule I have here, I have NH3, and write down the Lewis-Dot structure for NH3. We have already said in this case nitrogen is central atom and hydrogen is terminal atom, so hydrogen is here and we have to connect by one bond at least, and then count total electron. Nitrogen has 5 and 3 from hydrogen side, so total I have 8 electron, and 2 4 6 electron we have used, so rest electron we have, that is basically 8 minus 6, that is 2 electron we have. So 2 electron we can put on nitrogen as a lone pair, and now I can check the octet. Nitrogen had its octet complete and hydrogen had its duet complete. So this is about NH3. Now next molecule we have H2O. So this is again simple. So let us say if I have H2, oxygen will be treated here this time as a central atom, hydrogen will be terminal atom, connect by at least one bond. Now count down the total number of electrons. Hydrogen 2 electron, oxygen 6 electrons, so total 8 electron. We have used 2 electron here and 2 electron here, that is a 4 electron used. So rest electron I have, basically 8 minus 4, that is 4 electron I have rest. So this is 4 electron I can put as a lone pair on oxygen, and then I can check the octet. Oxygen has its octet, hydrogen has its duet, so everybody has its octet or duet complete. Now let us say I have molecule S3O plus. Are you getting or not? So S3O plus, one can expect oxygen as the central atom, hydrogen as a terminal atom, so we can put this hydrogen as a terminal atom. Now count total electrons. S3O, so 3 for hydrogen, oxygen has 6, but there is a plus charge, so I have to subtract 1 electron, so I have 9 minus 1, so we have 8 electron. We have used 6 electrons, so rest electron we have, 8 minus 6, that is we have 2 electron left. Are you getting or not? So we have 2 electron left that we can put as a lone pair on oxygen. Now if I find the formal charge on oxygen, oxygen has 2 4, and this is 1 2 3 4 5, because in case of formal charge we only consider half of the bond. So 5 electron has, one can expect for oxygen 6, so there is a formal charge of plus 1 on oxygen. So this is the Lewis-Dot structure of S3O plus. Now next molecule we have, that is N2. So this is slightly difficult. Now I have nitrogen, they are connected by one bond at least. Now see what is the nitrogen. It has 5 electron, valence electron. There are 2 nitrogens, so 5 into 2, basically I have 10 electron. We have used only 1 electron, so rest we have 8 electrons. So rest we have 10 minus 2, that is 8 electron we have. Now we can share 4 electron to one nitrogen and 4 another electron to another nitrogen atom. But now octet of 2 4 6 not complete. What we can do is we can make one lone pair into bond pair. So we can convert lone pair into bond pair. If I do this, now I will have something like this. Now if you see, this nitrogen has 2 4 6 electron, but this has 8 electron, 2 4 6 8. So what we can do is we can make another lone pair as a bond pair. If I do this, I will be having nitrogen, and then I will have a triple bond nitrogen. There is a lone pair and there is another lone pair. So this is the nitrogen molecule. So nitrogen molecule have a triple bonded structure. So that's why nitrogen molecule is very strong. It cannot be easily broken. So nitrogen, between nitrogen and nitrogen, there is a triple bond. Between N and N, there is a triple bond. Are you getting or not? So there is a triple bond. Now let us discuss the next one. I have HCN. So let us do for this one. Can you try this one? I will give you a hint. carbon is treated as a central, hydrogen is one terminal and nitrogen is another terminal. Carbon is less electronegative than nitrogen, and that's why this is a central atom. At least one bond should be there. And now you have 1 plus 4 plus 5, that is total is 10 electron. We have used 4 electrons, so rest we have 6 electrons, so 10 minus 4, so we have 6 electron left. We can place from nitrogen 2 4 6 because nitrogen is more electronegative, so first octet of this will be completed. Now see, carbon has only 4, so what I can do is if I give 2 to this lone pair converted into bond pair, carbon will have now have 6. Now if I also give this lone pair as a bond pair, carbon will also have 8. So if I do this, I will have H C triple bond N, and nitrogen will have one lone pair. Are you getting or not? This kind of a structure you see can be easily written. Now let us say you have another molecule. This is HONO, that is HONO, or I can write the same thing as HNO2. In this case I will give you hint, that is a nitrogen is here, oxygen is here, and we have one hydrogen and we have another oxygen here. So this is the skeleton. Now you can try now, at least one bond should be made there. Now hydrogen is 1, nitrogen 5 and 2 oxygen, so 2 into 6, so we have total 12 and plus 6 18 electron is here. So rest how many electron we have? So rest electron we have, rest electron 18 minus, that is 2 4 6 we have used, so we have 12 electron that is left. So 12, so let us start with oxygen. 6 will be put on this oxygen, and 6 4 we can put here and 2 we can put here, so this is 2 4 6 at 10 12. Now you see nitrogen does not have its octet complete. What we can do is we can make a double bond from this side. One can also make a double bond from this side, but if you make from this side you will see there is a formal charge. So if you make from this side there is no formal charge, and that's why this is a good Lewis-Dot structure. So we'll have nitrogen, oxygen, hydrogen, and then you have here oxygen. Now see 2 4 6 no formal charge, nitrogen 2 4 5 no formal charge, oxygen 2 4 6 no formal charge. But if you make a bond from this side, you see, let me do this one, 2 4 6 nitrogen. If you make a double bond from this side, and in this case oxygen will have plus formal charge and this oxygen will have minus 1 formal charge, and that's why this is not a good Lewis-Dot structure, because the Lewis-Dot, the most suitable Lewis-Dot structure should have least formal charge. So I can write here most suitable Lewis-Dot structure should have least formal charge. Are you getting? So this is a important point. So whenever you are deciding which is the better Lewis-Dot structure, you think in terms of formal charge. Now molecule CO2, one can easily do this one, and this case you have, this is the a skeleton. So carbon has 4, oxygen 2 into 6, so we have 12 plus 14 4 16, and let us say 1 1, so we have used 4, so rest we have 16 minus 4, that is 12 electron is still there, so we have to put 6 here and 6 on this oxygen. And now carbon has only 2 bond, it has to make 4 bond, so that octet complete. So let us form one bond from this side, and one can form one bond from this side, that is lone pair can be converted into bond pair. If I do this, I will have C double bond O, and from this side also C double bond O, and at this side you will have only 2 lone pair, and this side again you will have 2 lone pair. So this is the structure of CO2 molecule. Now let us say we have next molecule N2H2, and I will give you a skeleton. So this is the skeleton for N2H2. So just combine by 1 bond, and then you see N2 has 5 into 2 10 plus 2, so we have total 12 electron, and we have used 3 bond, that is a 6 electrons, so rest we have 12 minus 6, that is 6 electron. So what we can do is we can put 2 electrons, so 1 lone pair here, and so 4 plus 2 6 we have already done. So now we can convert this as a lone pair into bond pair, because this nitrogen has only 6 electrons. So if I do this, we will have HN. Now there is a double bond and lone pair and then hydrogen. So this molecule N2H2 is something like this. This molecule is called hydrazine. N2H2 is called hydrazine. Now next molecule we have C3H4. Sometime with a given one formula you can have more than one Lewis-Stardust structure. You see C3H4. So let us say there are two possibilities. I can make C3 and I can make at least one hydrogen should be there and another hydrogen should be there. Now I can also put this hydrogen. So one configuration something like this, one hydrogen here and another hydrogen here. So this is one configuration possible, that is one skeleton possible. One can think in terms of this also. There are three and one hydrogen here, another hydrogen here, and these rest of the two hydrogen, or one can put one hydrogen here and one hydrogen here. That is the another configuration one can have. Are you getting or not? Are you getting? At least you have to put one hydrogen on terminal carbon, because it cannot be simply carbon. So both of the terminal carbon, this carbon and this carbon, should have at least one hydrogen. So in this case one hydrogen, in this case it has two hydrogens. So let us try. Now we have C3H4. Basically this problem can also be done by double bond equivalent concept, but let us try by Lewis-Stardust structure. So 4 into 3 carbon plus 4, so the total is 16 electrons. So if I see this one, so we have used 2 4 6 8 10 12, so we have 4 electron left. So we can put 4 electron. Let us say we can put anywhere we can always put. So let us say we put 2 electrons and 2 electrons, 4 electrons. Basically now I am going to form a bond pair. If I form this electron as a bond pair, octet of this carbon is complete, and if I form a bond pair here, octet of this carbon is complete. So let us say what is happening here. So this is double bond C, double bond CH H. So this is a one possible Lewis-Stardust structure. Now if you see in this case, this is also a Lewis-Stardust structure. Now in this case again we have total, we have 16 electron, but we have used 2 4 6 8 10 12, that is 4 electron left. So we have 4 electron left. We can put 2 electron here. Are you getting or not? We can put 2 electron here. If I form a bond here and if I form a bond here, but if I form a bond here, what will happen? Now in this case this is not possible, because carbon will have basically, so let me try, let me see this one and then you can figure out what is the mistake. 2 bond here and 2 bond here and carbon, hydrogen, hydrogen. So this is not a good Lewis-Stardust structure, because in this case carbon is becoming pentavalent. Do you see? So this case carbon is pentavalent, and that is not possible. Carbon cannot be pentavalent. So this is a not good Lewis-Stardust structure. One can think of in this term. Now if you put this hydrogen, now if you put this hydrogen here, you can find one Lewis-Stardust structure. So let us say you have 3 hydrogen on one carbon and 1 hydrogen on this carbon. In this case you can form a Lewis-Stardust structure, because you have used 2 4 6 8 10 12, so we have 4 electron left. So in this case I have 4 electron left. So 4 electron we have left, we can put these 2 electron here, and we can again put these 2 electron here. We can form a bond here. So, and also we can form a bond from this side. Are you getting or not? So if I found 2 bond, so I will have, this is basically CH3. In short, I can write this is CH3, and then we have a C triple bond H. So this is a good Lewis data structure. This is alkyne, and this is generally called alene. That is a 2 Lewis data structure possible for all this formula C3H4. There are 2 Lewis data structure that is possible. Are you getting or not? So this is Lewis data structure 1. So this is Lewis data structure 1, and this is your Lewis data structure 2. But these two are not resonating a structure. These two are called isomers. So 1 and 2 are basically isomers. And in more general, it is called a structural isomer because there is a difference in a structure. So, or you can say this is a structural isomer. So this is a structural isomer. Are you getting or not? Now let us say we have a formula C3H6. Can you try what will be the Lewis data structure for C3H6? Now you see we can write 1, 2, 3, and let us say 1 hydrogen, 2 hydrogen, 3 hydrogen. We can put 3 hydrogen on this one, and let us see what happens. Now can we make, now we cannot make, because if I try to, this carbon is not a octet of this carbon is not complete. If I try to make a double bond somehow here, this carbon becomes pentavalent. If I try to make a double bond here, this carbon becomes pentavalent. Are you getting or not? If I make a double bond here, this carbon becomes pentavalent. So I cannot put 3 hydrogen on one carbon and next 3 hydrogen. So this is not a possible. Let us think some another possibility. So I have carbon, 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 and let us say why not we can try this hydrogen. We put 2 hydrogen here, 2 hydrogen here, and then let us see what happens. So we have 6 hydrogen, so 2 4, and then I at least have 2 more hydrogen, so we can put 1 hydrogen here and 1 hydrogen here. Again in this case, if I make a double bond here, because this carbon, octet of this carbon is not complete, if I make this double bond, this becomes pentavalent. So this is not a good Lewis data structure. So what we have to do is, let us try something different. So we have 3 carbon. Why not we put 3 carbon on 3 hydrogen on 1 carbon, and 1 on this and 2 on this, and try to make a double bond. Now it can be possible. You see how many electron we have? 4 into 3 12, and plus 6, so we have 18 electrons. So how many bond we have formed? 1 2 3 4 5 6 7 8. So 8 into 2 16. So left electron is 18 minus 16, that is we have 2 electron left. So 2 electron left, we can put this 2 electron here, and then octet of this carbon is not complete, so we can form a double bond. Are you getting or not? I think all of you are getting. So if I make a double bond here, we will have CH3CH, and then double bond CH2. So it is your task. You have to decide what kind of a skeleton you will have. This will come only from practice. So deciding a skeleton only comes from a lot of practice. Are you getting or not? Let us do Lewis data structure of N2O5. So this will be slightly difficult. N2O5, and I will give you a skeleton in this case. So I have nitrogen. Symmetry says there will be oxygen that should be in the middle. Are you getting or not? Because, okay, sorry, so this is your, so let me give you again a skeleton. So you have nitrogen, oxygen, nitrogen, oxygen, oxygen, and then oxygen. It says there are 5 oxygens, so each nitrogen set contain two oxygen. So this nitrogen contains two, this nitrogen also contains two, and one oxygen should be basically connected by both nitrogen. So symmetry says this should be the skeleton. Now can you try for the Lewis-Dot structure? So nitrogen has 5 into 2, 10, and plus 5 into 6 for oxygen. So 10 here and 30, so there are 40 electron we have. So let us make a single bond everywhere. And now you see we have made 1 2 3 4 5 6 bond, so that is the 12 electron we have used. So rest electron is 40 minus 12, so we have 28 electron. So we have to put 28 electrons. So let us first give to the nitrogen. So 2 4 sorry oxygen, 6 6 to this, 12, and 6 to this, and 6 to this. So we have used 24. Now give to this 4. So we have used 28. Now let us try to write form bond. So if I form a bond here, nitrogen octet will be completed. If I form a bond here, nitrogen octet will be completed. So let us say if I do this, I will have nitrogen, oxygen, nitrogen. Now there will be a double bond. So oxygen will have a double bond and it has only two lone pair. And now this oxygen will have three lone pair. And now here you will have a double bond. Oxygen will have two lone pair, and this oxygen will have only three lone pair. So it will have a, now you can calculate the formal charge. This oxygen will have a -1 formal charge, and this oxygen will have a -1 formal charge. In a better way, this structure can also be shown something like this. So there is a -1 formal charge, and then also you have nitrogen, there is a -1 formal charge. On nitrogen also you will have +1 formal charge. You can see here, because nitrogen has only 4 bonds, so nitrogen will have +1. So overall 0 charge, because this +1, this +1 cancel with these -1s. Are you getting or not? So there is no formal charge overall. Overall no formal charge. Overall no charge over the molecule. Are you getting? Let us write Lewis-Dot structure for SO2. Now this is SO2, sulfur is here, oxygen is here, oxygen is here. So we can form 1 bond, sulfur 6 plus oxygen 2 into 6. So we have 12 plus 6, 18 electrons. So we have used only 4. So we have 14 electrons left. So we have 14 electron left. So we can put 6 electron here and 6 electron here, 12, and rest 2 electron we can put on sulfur. Are you getting or not? Now you see sulfur does not have its octet complete, you have only, so we can form a bond. So if I form this, I will have oxygen and sulfur will have this, and oxygen this side we will have this. Now you see sulfur will have a +1 formal charge and oxygen will have -1 formal charge. Basically we can minimize the formal charge. So Lewis-Dot structure, good Lewis-Dot structure basically minimize the formal charge. So minimize the formal charge. So what we can do is we can form a bond here. So if I form this bond, oxygen is here and sulfur is here, and then double bond I have. And now in this case sulfur will have 6, so 0 formal charge. Oxygen has 6, 0 formal charge. This oxygen also has 0 formal charge. One can say in this case sulfur has basically expanded its octet, so it has 2 4 6 10 electrons. So sulfur has 10 electron, but this is fine because sulfur has d orbital. So say after the second period, so sulfur has d orbital, so it can have, more than 8 electrons. So it can have more than 8 electron. Are you getting or not? More than 8 electron. So this is okay. Now let us try molecule SO3. and I will give you a skeleton. So you have S, you have O, you have O, you have O. So this is the skeleton. Let us form at least one bond, and now you can count 6 plus 3 into 6. So total basically 6 into 4, 32 electron we have used. We have basically used only 6 electrons, so rest of the electron we have, so rest electron we have 32 minus 6, that is 26 electron we have left. So 26 means I have to put 6 electron on each oxygen, that the 24, and we can put 2 electron on sulfur. Are you Now you can find basically formal charge. This oxygen has -1, this smallest one, and this case also -1. Sulfur will have +1. So what we can do is at least we can form one bond here. So if I form one bond here, so I will have sulfur oxygen bond, and then I will have 2 electron, and then I will have oxygen. I will have oxygen here 2 4 6 2 4 6, and this sulfur will have one lone pair. Are you getting or not? Basically we have done one mistake here. This is 24 electron, this is not 32, this is 24. So I will have 24 minus 6 in this case. So let me rub this one. So this is 24, so this is only 24 electrons, so I have done mistake. So this is your 24 electron, and 24 minus 6, so we have 18 electron. So 18 electron we have left, so we can put 6 6 6, and there will be no electron on sulfur. This is basically mistake. So there is no electron on sulfur. So if you see, and there is a formal charge of 2 plus, because 1 2 3, so basically 3 plus, sulfur has 3 less electrons, so sulfur will have 3 plus formal charge. Are you getting? So sulfur will have in this case 3 plus formal charge. So what we can do is we can form a bond from this side, we can form another bond from this side, we can form a bond from this side. So in this case I can have a double bond here, and I can also have a double bond here, and in that case I will not have a lone pair. This will also not lone pair. So this is the Lewis dot structure of SO3. So finally I can say SO3 molecule will look like something like this. This is a trigonal planar kind of shape. We will discuss sometime later about the shape of molecule. Now this is not the end of Lewis dot structure. There are many more Lewis dot structure. We'll discuss sometime more Lewis dot structure of inorganic molecules. So we'll discuss more Lewis dot structure. So Lewis dot structure discuss of, or you can say complex molecule. This we will discuss sometime later.